All right, let's get going through 1.2 now. Again, most of this is filled out, and I'm just going to talk about it. So pause it when you need to, when you need more time to write or think about something. And rewind if you need to hear it again. So what we're going to talk about here is linear equations and rational equations. So a linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. If a equals 0, then our variable is gone, and we just have b must equal 0. And we essentially have just 0 equals 0, and it really doesn't mean anything. So we have to have the variable in there. So a, that coefficient, cannot be 0. All right, so we're not going to have anything like x squareds and stuff like that. That would not be linear. So let's take a look here. Solve and check each linear equation. So this is all about just going through and trying to solve these things by doing the reverse operations of what is there. So we have 7x minus 14 equals 0. So we want to isolate this x by itself to solve for what its value is. So we want to do the opposite of all of our operations in the opposite order we would do it. If we plugged a number in for x, the first thing we'd do is multiply it by 7 and then subtract 14. So in order to solve for this, we're going to do the opposite of those operations in reverse order. So first we multiplied 7, then we subtracted 14. So we're going to start by adding 14 to both sides. What you do to one side, you have to do to the other. And then after you do that, we're going to divide by 7. So that's dividing by 7 instead of multiplying by 7. So we're doing the reverse operations in reverse order. Okay, that's essentially the main trick for isolating a variable or solving for a variable. So that's what we're doing here. So I add 14 to both sides. That gives me 7x. 7x equals 14. You then divide both sides by 7, and you get x equals 2. And just try to make sure you recognize the reverse operations of everything. The reverse of addition is subtraction. The reverse of subtraction is addition. The reverse of multiplication is division. And the reverse of division is multiplication. Okay, so that's all we're wanting to do is kind of undo everything that's being done to it, like working backwards. So over here we have 2 times x plus 3. So to get that x by itself, we're going to want to do the same operations but in reverse. So here we're going to do, instead of plus 3, we'll do minus 3 on both sides. That gives us 2x equals 14, because 17 minus 3 is 14. And then we divide by 2 on both sides. And we get 2x divided by 2 is just x, and 14 divided by 2 is 7. So just go through and do all your algebra rules and do everything you know and get through it. Now we come to this one here, it's a little different because our x, our variable, is 1, it's on both sides, and 2, it's inside parentheses. Okay, so the first thing we need to do is get it outside of parentheses. So we're going to distribute. That means I'm going to multiply this 2 in onto the x, and then I'm going to multiply it into the negative 3. That gives me 2x minus 6. 2 times x is 2x, 2 times negative 3 is negative 6. And then I just bring along the negative 16, the minus 16. Over here I have 13 minus, and I'm going to do 3x times 3 times x, and then 3 times 2 to distribute that one. And that gives me 13 minus 3x minus 6. So I distribute it, I get rid of it, get it outside of parentheses by distributing and getting rid of the parentheses. Now at this point I want to start combining like terms on each side of the equation. So here I've got a negative 16 and a negative 6. Neither one of them have an x on them, so I can combine them. Negative 6 minus negative 16 is this negative 22. On this right-hand side, I have this 13 and then this negative 6. So I have 13 minus 6. That gives me this 7 right there. And so I come down to the next line, and I have 2x minus 22 and 7 minus 3x. So that's all my common things. So now that I've simplified each side of the equation, I want to get all the x's on one side and all the non-x terms on the other side. So first thing I want to do is add 22 to both sides to get rid of this minus 22 right there. And so I add a 22 to both sides, and you end up with 2x minus 22 plus 22 is just this 2x. And then on the other side, you end up with this plus 22 here, and you have 7 plus 22. That gives us this 29 right there. So now what we have at this point is 2x equals 29 minus 3x. But I still have x's on both sides. So what I'm going to do is I have this minus 3x right there. I have this minus 3x, and so I want to get it to the other side. So what I'm going to do is add 3x to both sides. So it cancels out on this right-hand side. Negative 3x plus 3x is just 0. And we'll end up getting 5x equals 29. That's the 2x plus 3x gives us the 5x. All right, and now I have to just finish isolating x by itself. I have 5x equals 29, so to get rid of that 5 times, I do the opposite, and I do a divide by 5. And so I divide both sides by 5, and I get then just x on the left-hand side, and I get 29 over 5 on the left-hand side. And then that's my value for what x should equal. Okay? What I would probably then want to do real quick is plug this back in up here for x, and I'll do that in some of them here coming up on the next page, you'll see it, and make sure that the two sides end up equaling each other. I will plug it into this right-hand side and solve this right-hand side by itself and get a number, and then plug it into this left-hand side and solve the left-hand side by itself, get a number, and see if the two numbers equal each other. If they do, then I'm good, I've checked it. If they don't, then I must have made a mistake either during my check or while finding my result. All right, so let's go on here to the next two. I've written the answer down for you. X equals 2/3. So what I want you to do is try solving that one yourself. You should try going through and doing that one. Same thing for this one. Try seeing this one and why there is no solution here. Okay, see if you can do that one and solve it, and then well, no solution, or basically any number will work as a solution. So, but there's no single solution there. So try solving those two, see how you do. Over here on this page, I've given you some answers again. So try working on some of these. Pause the video now and go through and work on these. This one's very similar to the one on the previous page where we could have had just really anything. And then same thing here. And then here's the answer for that one. So see if you can solve those, and then also try plugging them back in and checking. Okay? Next page. Here are linear equations, but this time we have fractions involved. And so what we're going to want to do here is eliminate the denominator by multiplying by both sides by the least common denominator. In other words, the smallest number divisible by every denominator. All right, so we look at this first one. We have x plus 2 over 4 minus x minus 1 over 3 equals 2. You can see I wrote a 2 and I wrote a little divided by 1 because that's essentially what 2 is. It's 2 over 1. So we essentially have all of these as fractions, and we want to think what is the smallest number that all of these can be, all of these will go into evenly. And the answer for that here this time is 12. If you can't find the smallest one that they all go into, you can always go the difficult way. It might make it a little trickier, but you can just go by multiplying all the denominators together. 4 times 3 times 1 is 12, and then that one will work. So 4 times 3 gives us 12, which happens to be also the smallest one that they'll all go into. And we're going to multiply everything by 12. So we end up with 12 times the x plus 2 over 4, and 12 times the x minus 1 over 3, and then 12 times 2 is 24. So here what I can do is divide the 12 here by this 4. That gives me a 3. And I can divide this 12 here by this 3, and that'll give me that 4 right there. All right, and so now what I've essentially done is ended up with a nice little version of the equation here. Let me get rid of all this other marks. That does not have any fractions in it. All right, we got rid of all the denominators. And so now it's just a matter of distributing and then combining all our like terms, getting all the x's on one side. So here we distribute, here we get all of our terms together, combine all our like terms, and then it's about getting all the x's on one side and all the other numbers on the other side, and then just simply dividing by whatever is left, in which case this is negative x, which is negative 1 times x. So we divide both sides by negative 1, and we get x equals negative 14. All right, and then over here I did a check, which I talked a little bit about on the previous page, where I plugged this 14 here, or this negative 14, back in for x. And then I checked to make sure that when I did it, I ended up getting both sides equal to each other. So be careful when you're doing these checks. You never want to start swapping things from one side to the other. You want to work entirely on just one side by itself and entirely on the other side by itself. Now in this case, the right-hand side really didn't have any work that needed to be done, but you wouldn't want to like subtract 2 from both sides or something like that. You don't want to do something to both sides. You want to work on one side at a time and show then that at the end you get the two sides that equal to each other. All right, so work on one side at a time, go through and do a check. You can mess yourself up, like if you had something like 4 equals 3, if you do the same thing to both sides, you know, we know this isn't true, but if I multiply both sides by 0, I get 0 equals 0, and you say, hey, look at that, 4 does equal 3. So you only want to work on one side at a time. You don't want to do the do one thing to a side and do it to the other side as well, okay? So just one side at a time. The next one here, you can go through and check. This was about getting rid of the 2 and the 3. The smallest thing that does that is this 6. So I multiplied everything by 6, and you have 6 over 2, that gives us this 3. We have 6 over 3, which gives us this 2, which I then distributed through 2 times x, that gave us 2x, and 2 times 2, that gave us this 4. And so at that point, I have no fractions left anymore, and it's just a matter of going through and doing the same thing we did before. Combine the 3x and the 2x to a 5x, bring down the 4, so we have 5x plus 4 equals 30. Subtract 4 from both sides to get rid of that 4, and we end up with 30 minus 4 is 26, and we have just the 5x left, and then divide both sides by 5, and you get x equals 26 over 5. Again, I went through and did a check. You can see the check is right here, and in the end, I ended up working one side at a time and getting 5 does equal to 5. I just carried the right-hand side along because there was nothing to do to it. So that one works. There's a good answer there. This next one, you want to go ahead and try on your own. You should end up getting x equals 20, which if you go through and check, you'll see 20 divided by 4. So if we plug in 20 and 2 times 20 right there, you get 20 over 4, which is 5. 5 plus 3 is an 8. And then on this side, you get 2 times 20, which is 40. 40 divided by 5 is 8. So go through and see, there you go, I did a quick little check for you, but go through and try this one and see if you can get x equals 20. See if you can come up with a least common factor for both sides there. All right, so the next one you can see I did the same sort of thing here. Here, it's a little trickier because, and I'm going to zoom in on this one just to show you, the x's are in the denominators, right? The x's are in the denominators. So I have to think of what is a common denominator that will get rid of the x's, that'll get rid of all the x's, and also end up getting rid of my fractions. And so when I look at this, the numbers that I have are 5 and 2. And so I'm going to multiply everything by 5 and 2. And then the other thing I want to do, and you can try doing just 10x and see how it goes, but I did 10x squared here. And go ahead and try this one on your own, but try doing only just 10x without the squared and see if it makes a difference for you, okay? Ultimately, you should get that x equals 5 over 2 after you go through, distribute, and do everything that you need to do with that, all right? And so just follow my work there and see if you can go through and do that one. All right, last one over here. Again, I want you to look through and see if you can follow my work here. 4, 14, and 7. I picked 392. 392 might not be the least, the smallest common multiple for each one of them. In fact, 28 would be the least common multiple for both of them. But what I wanted to do here is show that even if you didn't recognize that they all went into 28, which you could have done, if you'd noticed it, you could have multiplied everything by 28 and done it. But what if you didn't notice it? You can ultimately just go by doing by multiplying these all together. 4 times 14 times 7, and that'll equal that 392. And you can actually just go ahead and use that and go through and do it. 392 isn't as easy to work with as 28 would have been, but ultimately you can still get it done by doing that. So take a look and follow through that one, and then also try it using 28 and see if you still get x equals 1. And of course, all these ones where I didn't do checks for you, you should try doing checks to make sure that they actually still end up equaling each other. All right, that's pretty much it for this one, and I'll see you in the next one.